Okay, now we're going to talk about a much better method of solving these nonlinear systems, and that's going to be with algebra, with substitution and elimination, the same way that we solve our linear systems. So let's start out with the substitution method. The substitution method works the exact same way. You solve either one or the other equation for either x or y. Notice that the second equation is already solved for y. Y is equal to this. You simply take and plug that into your other equation. So your other equation, 4x plus y, now turns into 4x plus x squared plus 5x minus 2 is equal to negative 20. So you've completely eliminated your y's by using substitution. Now you just clean it up and solve like normal. X squared, it's quadratic, so let's combine our like terms. 4x and 5x gives you 9x. Let's take this minus 20 and move it over here, and that would give you a plus 20, which is now a positive 18. Let me zoom in just a little bit. From here, we now, since it's quadratic, we're going to solve it by factoring. X times x gives you x squared, adds, multiplies is a positive 6 and a positive 3. So that gives me x is equal to negative 6 and x is equal to negative 3. Now you got to be careful because before we were done in the previous sections. However, what we're looking for is the 2 points, or the points, in this case it is 2, where these two things cross. So we only have an x value here for a point, and we have another x value. That tells me that there's 2 different x values, so there's 2 different points of intersection. So how do we find the y's? Same way we always have. We always just plug it back in. So I would probably take the 4x plus y equals negative 20. Since it's linear, it's going to be easier to plug it in. Let's plug in negative 6 first. So I now have negative 24 plus y is equal to negative 20. Move your 24 over by adding, and you get that y is equal to 4. So negative 6, 4. Do the same thing for negative 3. You have 4x plus y equals negative 20. When x is negative 3, you have negative 12 plus y is negative 20. Add the 12 by moving it over, and that's going to be a negative 8. So when x is negative 3, y is negative 8. There is your 2 points of intersection. Now, elimination does also work. You got to be a little bit careful, though, because elimination won't always work. But what you're going to do, you're going to line up all your like terms. Notice in this one, it's already lined up. Y's lined up with y's, x squareds with x squareds, x's with x's. And you're going to do the same thing. You're going to make sure equals are lined up with equals, and you're going to either add or subtract these two equations. In this case, we're going to subtract the 2 because when I do, y minus y would cancel. Elimination method makes you got to make sure that something, one of the 2 variables, completely cancels. Like if you're going to cancel x's here, you got to make sure x squareds and x's both cancel. But the y's cancel completely, so we're fine. X squared minus x squared actually cancel out as well. 3x minus 5x gives you negative 2x, and 2 minus negative 4 gives you a positive 6. Minus a minus is a plus. And there's what you're left with. So you have these 2 parabolas. Solve this equation that you're left with. Move this 6 over by doing minus 6, and you're left with x equals 3. So this thing is only going to have 1 point of intersection, 3 comma. To find the y value, we go back and we simply plug that in. We'll plug it into this one. So you have 3 squared is 9 plus 2, so 3 comma 20 is the point of intersection. And you can already see that would have been hard to find with a graph because the graphs that we usually use only go up to 10 on the y-axis, so therefore that wouldn't even fit on our graph. So now let's work some more examples. This one I'll solve with substitution. You can solve with elimination because y's would very easily cancel out. But we're going to take y equals x plus 3, and we'll solve it in, or we'll plug it in for every x. So my first equation y equals x plus 3. Let's plug that in for y. I had that backwards. So I now have x plus 3 equals x squared minus 3x minus 2. Since it's quadratic, let's move everything to the same side. I'm going to move the x over by doing minus x. I now have minus 4. Move the plus 3 by doing minus 3. I now have minus 5, and it's equal to 0. 0 equals, let's factor. X times x is x squared, adds, multiplies, negative 5, and a positive 1. So I get x is 5, and I get x is negative 1. So my 2 points are 5 comma something and negative 1 comma something. Again, the best place to plug it in, look, y equals x plus 3. So therefore, I can simply do y is equal to 5 plus 3. Plug this in, you get 8. Y is equal to negative 1 plus 3. Plug that in, it gives you 2. So there's my 2 points of intersection would be 5, 8, and negative 1, 2. Next problem. Again, let's use a substitution here. Second equation, I can move the 2x over and I get y equals negative 2x minus 1. So let's take that y value and plug it into our first equation for y, and I now have negative 2x minus 1 equals negative x squared minus 8x minus 6. I'm going to move everything to the left so that I can get this negative x squared positive. So that's going to be a positive x squared. Move minus 8x by adding. I now have negative 2 plus 8, which is 6. Minus 6, move it over by adding. Negative 1 plus 6 will be a 5. So therefore, there's the everything moved over. Let's factor it. X times itself gives me the x squared. Adds, multiplies is a positive 1 and a positive 5. So my two different x values are negative 1 and negative 5. Let's plug those in. Again, right here is a great place to plug it in. Plug in negative 1 gives you negative 2 times negative 1 is 2 minus 1. Negative 2 times negative 5 is 10 minus 1, which gives you 9. So there's my 2 points of intersection. And you can always check that with a graph. You would have an upside down parabola. You're going to have 2 different points of intersection if you were to graph this. The next one, just because we haven't done it yet, we'll solve this with elimination. So we need to make sure everything's lined up. So I'm going to write y equals 2x squared plus 20x plus 46. And I'm going to line up everything in my other equation with that. I've got to move my 3x over. So I'll have negative y, and I left that as negative y for a reason. My 3x, when I move it over, becomes negative 3x, and that's going to line up with my 20x, and my positive 7 lines up with my 46. So make sure to line up all your like terms. Either x's or y's must cancel, and here, obviously, my y and negative y, when I add those together, cancel. 2x squared adds with nothing. 20 minus 3 gives me 17x, and 46 and 7 gives me 53. So I'm left with a basic quadratic equation. I am going to have to use slip and slide if this is to factor. And you can try to do that, but this will not factor. So our next go-tos, we can try to complete the square since there's a number out front and this is odd. That's the worst method to use. So let's go to our quadratic formula. And let's always work our b squared minus 4ac first. So I've got 17 squared, which is 289, minus 4 times a times c, which is 424. So 289 minus 424, that's going to give you a negative 135. And again, here's another reason I always do this first. That's under the square root. The square root of a negative, that's going to be an imaginary number, which means there's not a real solution here. So therefore, this will have, the x values will have no real solutions. There's no 2's or 3's or 5 plus the square root of 5 or anything like that. So therefore, there is no solution to this. Anytime you have imaginary numbers on this, there's not going to be any real place where these two cross. Okay, number 4. We have a circle and we have a line. We really don't want to try to get x's or y's to cancel, so our best method here is going to be substitution. Y equals x plus or x minus 6, so plug that in for y. We now have x squared plus, in the place of y, we're going to put x minus 6 equals 18. Let's distribute that, FOIL it out, gives you, now we're squaring a term, so there is a shortcut. Square the first, multiply them and double it, and square the second, and there's what you get. Let's combine all of our like terms. X squared and x squared gives me 2x squared. Since it's quadratic, let's move everything to the same side. Minus 12x, move the 18 over, gives me a positive 18 when you subtract those. Everything here is divisible by 2, so I highly encourage to divide all 4 of these terms by 2 and clean this thing up. It makes it a whole lot easier to solve. Let's factor this. This is a perfect square. If you half and square this, you do get 9. So therefore, this is going to factor into x minus 3 times x minus 3 is equal to 0. So take the square root to get rid of the square. It gives you 8. X minus 3 is 0. So x is equal to 3. So there's only one point of intersection here. And it's located at 3, comma. When you plug that 3 in here, 3 minus 6, your y value would be negative 3. So the only point of intersection is going to be 3, negative 3. So since you had a circle and you had a line, what that would mean is this must just skim the circle. If it only has one point of intersection, the word there would be tangent. Number 5. You have, looks to be here, since your x squared and y squared signs are different, this is going to be a hyperbola and a line. Really, it doesn't matter what shapes they are because all of these are now solved the exact same way. I'm going to take my second equation and I'm going to solve it for x. And very easy to move x over here, and it's going to give you a positive x is equal to 2y. And I'm going to take and plug that positive 2y in for my x. So my first equation is now y squared minus, in the place of x, again, I'm putting 2y. Plus 75 is equal to 0. So you now have y squared minus, square both of these. You don't have to FOIL it because there's no plus or minus signs. Plus 75 is equal to 0. 1y squared minus 4y squared gives you negative 3y squared plus 75 is equal to 0. Now we can solve this one by taking a square root. Since there's no b term, this is quadratic, but there's no b term. So let's move our 75 over. Gives you negative 3y squared equals negative 75. So therefore y squared, when you divide by negative 3, gives you 25. When you take a square root, make sure to get rid of a square. Make sure you plus and minus. So y is equal to plus and minus 5. So therefore, you have 2 points. You're going to have something, comma, 5 and something, comma, negative 5. Now, how do you find the x's? Again, if you're using substitution, this is the best place to plug it in. When you plug in 5 for y, it gives you 10 for x. When you plug in negative 5 for y, it gives you negative 10 for x. There's your 2 points of intersection. Okay, number 6. This one, since you have just y and y, we can solve this by using elimination since we hadn't done that in a while. These are already lined up perfectly, so you can simply, to get rid of the y's, we're going to subtract the 2 equations. Y minus y gives you 0. 2x squared minus 1x squared gives you 1x squared. 3 minus 2 is 1x. Negative 19 minus minus, that's negative 19 plus 7 would be a negative 12. So that was kind of quick and easy. Let's factor. X times itself gives you x squared, adds to give you 1, multiplies would be a positive 4 and a negative 3. So therefore my two x values will be a negative 4 or a positive 3. To find your y values, again, let's simply plug them in. Since this is a simpler equation, let's plug it in here. When you plug in negative 4, it gives you 16 minus 8, which is 8, minus 7, which is 1. When you plug in 3, it gives you 9 plus 6, which is 15, minus 7, which is 8. There's your 2 points of intersection. Number 7. Again, these are lined up perfectly. If you'd like to just solve these with elimination, it'll be pretty easy. Let's subtract our 2 equations. Y minus 1 is 0. 4x squared minus 1x squared gives you 3x squared. Negative 29 minus negative 17 is negative 29 plus 17, which is a negative 12. Now this one's even simpler. You don't have to factor it. You can solve this one by taking a square root. Let's move our 12 over. Gives you 12 equals 3x squared. And again, the reason you can do that is you're missing your b term in this quadratic. Divide by 3 gives you 4 equals x squared. Since x squared equals 4, then that means that x will equal, when you take the square root, make sure you do plus and minus the square root of 4, which is 2. So therefore, your two x values will be 2 and negative 2. You can plug those into either one. This one's probably the simplest. So when x is 2, your x squared minus 17 will be 4 minus 17, which is negative 13. When it's negative 2, you get the exact same answer because this is an even function. It has y-axis symmetry, and it's going to be the same point on the other side. Okay, number 8. I believe this is the last one. Now, let me show you something that we've never done before, and this is legal. You can use substitution here. And on my first equation, what I'm going to do is I'm going to move my 2y squared over. And I've got x squared equals 17 minus 2y squared. Now, normally when we use substitution, it's like an x equals or a y equals. However, notice that when I solve this for x squared, that I can actually plug in an x squared down here and I can get rid of all the x's. You don't have to go this extra step. You can simply, once you see x squared is equal to this and x squared is what I need to plug into, I can stop there and leave it as x squared. And in the place of x squared, I'm going to plug in this. So 17 minus 2y squared in the place of my x squared. So now I have completely gotten rid of my x's. So I have 34 minus 4y squared minus 3y squared equals 6. That'll be 34 minus 7y squared is equal to 6. Now this is quadratic, but you don't have a y term. You're missing that, what would normally be our b term if this was in standard form. So we can solve this by, again, taking a square root. So I'm going to move my 34 over. So I now have negative 7y squared equals 6 minus 34, which is a negative 28. Divide by negative 7 gives me y squared is 4. So my y value is going to be positive and negative 2. Now let's plug that in. So when I plug in, now this is going to be a little tricky. When I plug in 2, when y is equal to 2, let's plug it in here. Okay, so I get x squared equals 17 minus, when y is 2, I get 2 times 4, which is 8. So that'd be x squared is 9. Notice what happens. You have two different x values. When you take the square root of 9, you get positive negative 3. So when y is 2, x is 3 and x is negative 3. So let's do it like this. When y is 2, x could be 3. Or when y is 2, x could be negative 3. That's two different points. Well, let's do the same thing for what about when y is negative 2? When you go to plug it in here, you might already notice you're going to get the exact same thing. When you plug in negative 2 and you square it, you get 4. 2 times 4 is still 8. And you go through the same process. So when y is negative 2, you're also going to get 3, and you're going to get negative 3. So this thing has 4 different points of intersection. And we'll take a look at the graph, and let's see why this is true. But before we do switch over and look at the graph, I do want to remind you, look at your x squared and y squared terms. Since your numbers out front have the same signs, your coefficients, but they're different numbers, this should be an ellipse. On the second one, since your coefficients are different, you have a positive and negative, that'd be a hyperbola. So when we switch over and we look at the graphs, again, we do have an ellipse and a hyperbola, and notice the points of intersection. You see the symmetry, negative 3, 2, and positive 3, 2. Negative 3, negative 2, and positive 3, negative 2 would be your 4 points of intersection.